This video shows you how to find rate of change. Okay, there are 5 steps to find rate of change using the acronym DEEDS. DEEDS. The first is D. D refers to diagram. Diagram. Draw a diagram and label. Okay. The second is write an equation for the quantity. Okay. So the quantity is volume, the rate of volume, area, surface. Okay. And the third is EX, express the quantity, okay, as a function in a single variable. Okay. And then the second D is D1, differentiate the expression. Differentiate EX. Okay. And then the last is S, solve. Solve, we have more than one method to solve. Okay, here is first using chain rule, or we can be solved using direct or implicit differentiation. Okay, so when to find the rate of change, please think about DEEDS. Okay, diagram, equation, express to single variable, find the first derivative, differentiate, and solve. Solve using the chain rule or direct or implicit. Okay. Example, water is poured into a right inverted cone, okay, of height h with a semi-vertical angle of 60 degrees and at constant rate of 25 pi cm cube. Okay, find the rate of change of the height of water. So now here is this is inverted cone, right? Inverted cone. The cone is like this. Okay, the cone and height h. Okay, with a semi-vertical angle of 60. So h vertical angle of 60 degree here, 60 degree at constant rate of 25 pi. So rate refer to d over dt. Okay, and then this one is equal to 25 pi cm cube per second. So this one this unit refer to volume. Cm cube refer to volume. So now this is dV dt is equal to 25 pi cm cube per second. So just check the volume. Okay, and then find the rate of change of the height of the water. So rate involve d and h, dh dt. Find dh dt. Okay, our aim is to find dh dt. So using the DEEDS, okay, the first step is draw a diagram. Cone. This cone. Okay, this is h height and r. So draw a diagram and label. Okay, the next step is here is 60 degree. 60 degree here. Semi-vertical angle. Okay, settle. Then you given info dV dt is equal to 25 pi cm cube per second. To find dH dt. Okay, the next step is EQ. Okay, write an equation. Okay, this is consider V. This is V. So write a volume. Okay, volume is 1 over 3 pi r square h. How to remember the volume of the cone? Just this is pi r square h is volume for the cylinder. Just take 1 over 3. Okay, now here is variable r and h. 2 variable. We need to reduce to single variable. Okay, now we're going to find dH dt. So we should get rid of variable r. So now find the info that relates between the two variables. So given info only this one. Okay, this one is the triangle. Okay, this triangle. Okay, this triangle. Okay, 90 degree. R, H, and 60 degree. Okay, so relation between R, H, 60 degree is tangent. Tangent 60 degree is equal to R over H. Okay, so to get rid of variable R here, we need to write R as a subject. Okay, R is equal to H. Tangent 60 degree is equal to sec 3. So sec 3 H. Substitute here. Okay, sec 3 or R sec 3 H to this one. Okay, into here. Then the third step is EX. Express V into single variable. So V is equal to 1 over 3 pi H. So now R squared is here. Substitute R is equal to sec 3H. Okay. Define V is equal to sec 3 squared is 3, so cancel. Pi H. Okay, this is V in single variable H. Independent variable H. V is dependent variable. The next is D. D1, find the first derivative. Okay, and this one, okay, after this step you have two methods. You have two methods. And the method one is using to solve this one using chain rule. Method 2, solve this one using direct or implicit. Okay, now given V pi H cube, V pi H cube. Okay, we try the first method. Okay, differentiate V with respect to H. Answer is 3 pi H squared. Using chain rule, dv dt is equal to dv dh dot dh dt. So given is info dv dt is equal to 25 pi cm cube per second. This is given info to find dh dt, right? Okay, and substitute here dv dt. And the next is this one is dvdh. Here dvdh. So dvdt is 25 pi. dvdh is 3 pi h squared. Then we're going to find dh dt. Okay, dh dt as a subject. Okay, is equal to 25 pi over 3 pi h squared. Okay, and then dh dt is equal to cancel 25 over 3 pi squared cm per second. Okay, done using the first method. The second method, we're going to differentiate this formula. So to find the rate means differentiate with respect to t. Now direct differentiate with respect to t. Okay, differentiate both sides with respect to t. Then this is v pi h. Then differentiate with respect to t, dv dt. And here it's direct 3 pi h squared. dH dt. How to get this one? Actually, this one also using the chain rule. Okay, here. Okay, so now you want to differentiate this part. Okay, this one. Okay, so d over something pi h cube over dt. Now this one actually dh. Cancel, still get d dt. So now can differentiate this part to get 3 pi h squared. Then dh dt, just like dh dt, cannot be cancelled. Okay, and the next step is, okay, take dh dt. We go to find dh dt, right? Take this one as a subject. Okay, dh dt is equal to dv dt is given 25. This one, 25 pi over 3 pi h squared. Then 25 over, cancel, 3 h squared. cm per second. Okay, so this is the answer. Okay, so whatever method, you get the same answer. It's up to you to choose whatever method. Okay, continue to answer this question. Find the rate of change of the height of water after 5 seconds. Okay, rate of change of height dh dt when t after t 5 seconds. So now to find dh dt after 5 seconds, we must find the volume. The formula of the volume is pi h cube, right? Okay, pi h cube, yes, here. Given dv dt is equal to 25 pi cm cube per second. This is step S, solve. Okay, step S, solve. So before you find the dH dt, we have to find volume. Why? Because of the pattern of the cone is like this, okay, become smaller size, become bigger and bigger. Now we're going to find volume. Okay, to find the volume, we need to find, okay, volume after 5 seconds. So this one, 1 second, V is equal to 25 pi cm cube. And then 5 seconds, it implies that V is equal to 25 pi times 5. That is 125 pi cm cube. So we're using this V, okay, this volume, to find H. So V is equal to pi h cube, and V is equal to 125 pi equals pi h cube. Okay, and h is equal to subject 125 pi over pi. Therefore, h is equal to 5 cm. Okay, now 5 cm. Substitute here to find dH dt. Okay, from the previous, dH dt is equal to 25 over 3 h squared. Okay, let's check. Yes, one. Then substitute h here. Substitute this one. Okay, h to here. Okay, then dH dt is equal to 25 over 3 5 squared. Okay, and then the answer is 1 over 3 cm per second. So the answer is 1 over 3 cm per second. This is under S, solve. So using the acronym, okay, DITS, can use this one, the acronym, to solve, to find the rate of change. D diagram, EQ is here the equation, and express this equation for in the a single variable. Okay, differentiate first derivative and solve. Okay, this.